All right, here we go, friends. All right, so here we go, number 2. The graph of a quartic polynomial is shown. What does quartic mean? Degree is 4. Determine the number of x-intercepts of f. So it doesn't ask me what they are, it just says how many are there. Well, how many x-intercepts are in that picture? 3. Now, do you notice that the behavior at -2 is different than the behavior at 1 and 3?
Yes.
That bounce off behavior means that particular factor is squared. So if we were writing out the factors of that polynomial, it doesn't say that, it says determine the number of x-intercepts. There are 3 of them. The x-intercepts are -2, 1, and 3. But the factors of the polynomial would be x plus 2 squared, because that one happens twice. And how do I know it happens twice? The curve bounces there. And then x minus 1, x minus 3. Is that okay? We're going to talk more about that today. But is that good with everybody? You've done that before. That looks familiar. All right. Determine the number of relative minima and label them. Okay? So how many relative minima do we have? 2? Where's one of them? -2, 0. And where's the other one? 2.2 comma -3.5 or something like that. Would you agree with that? Okay. How many relative maxima do we have? This one's a little bit tricky. They tell me in the directions this is a polynomial. Polynomials stop. No. So even though they didn't put arrows on those things, they are going to go forever and ever. So there is one maximum, one relative maximum, and that is at -1.2, or excuse me, -0.2, comma 2.4. Something like that, estimated. How many times does a graph change concavity? So in other words, how many times does it go from being concave up to down and vice versa? What do you think? How many times does it change concavity? I think it changes right here. And right here. And I think that's it, isn't it? So twice. Label the absolute minimum or explain why this value does not exist. Do we have an absolute minimum? We do. And it's the one that's at, I can't remember what I said before, but like 2.2, -3 point something. This one right here. Label the absolute maximum or explain why it does not exist. Already talked about it. This is a polynomial. They told me in the directions. So there are arrows here, even though they didn't write them. Because polynomials don't stop. There is no maximum. A polynomial function has x-intercepts at 0 and 4. Which of the following statements must be true? So I got something that has a 0 at 0 and 4. Which of those has to be true? Does it have to be quadratic? Could be, for sure, but it doesn't have to be. Does it have to change concavity between these 2 points? No, couldn't it work like that? That's concave down the whole time, so no, that's not true. Has an absolute maximum or minimum at 2. Not an absolute, no. It could, if it's a parabola, for example, it could, but it doesn't have to. I hope it's D. There's a relative maximum or minimum somewhere in this interval. Yeah, that's true. That's true. So it's D. D is the true one. Okay? All right. Fix my attendance real quick, and let's move on to the next section. That's Mrs. Brandis, right?
Yeah.
All right, here we go. What's in the box up here? Given a polynomial function of p of a is 0, then a is a 0, or root, x-intercept. If a is a real number, then if x equals a is a 0, then x minus a is a factor. We've already talked about that. Okay, sometimes when we put the math language to it, it gets a little confusing, but we've already talked about that relationship. If a linear factor, x minus a, x plus 2, is repeated n times, the corresponding 0 has that multiplicity. Did you use that word last year, multiplicity? So if your factor has a power on it, then that root is going to have that multiplicity. Typically, we know that the graph of a polynomial passes through the zeros on the graph. This is the normal behavior. It passes through the zeros. But occasionally, when you put a power on that factor, it's going to behave differently. If the power is even, we've only talked about squared, but if it's even, you're going to bounce off. All right, so they've graphed one for you over here. Here's this crazy function. Okay. Notice the behavior around the zeros of the function. The multiplicity of a 0 is the power of its factor. And we include the multiplicity when we list the zeros. So, let's look at that picture. Would you agree there's a 0 at -4? And notice, what is the curve doing there? It's just kind of zipping right through. That means that factor occurs one time. But what happens at -1? It goes through, but it doesn't just go through. It kind of curves its way through. That means the power on that factor is odd. So it's going to be something like x plus 1 cubed, x plus 1 to the 5th, x plus 1 to the 7th. And then what happens at 3? At 3 it bounces off, and that means the factor has an even power. So that's behavior for a squared or fourth power factor. Complex roots. Some polynomials have roots that contain an imaginary number. You know that. That means you're not going to see them on the graph. These are real roots. Complex roots, you don't see them on the graph. So the graph of x squared plus 1 is shown to the right. To find those zeros, you would just solve that equation, and you would get your imaginary roots. All right, next page. Key understanding. All imaginary roots come in pairs. If a plus bi is a root, then so is a minus bi. That is called the conjugate. Anytime you have a complex root, an imaginary root, you will have its conjugate also. So, let's practice finding conjugates, and then we'll see where we go from there. What's the conjugate of 4i? -4i. 4i is 0 plus 4i. So the conjugate would be 0 minus 4i. Negative I. What's the conjugate of negative I? I. 2 minus 3i. 2 plus 3i. Negative 4 plus 2i. Negative 4 minus 2i. In the box there, kind of a big idea. If you have an x cubed polynomial, there's going to be 3 roots. 3 roots. If you have an x to the 5th, you're going to have 5 roots, and so on and so on. Now, some of them might be multiplicities. Some of them might be repeated, but you're going to have a total of that many. All right, example 2. We got a picture of a function. We know that I root 3 is a root. So the picture is right there. We know I root 3 is a root, or 0. What is the smallest degree that that function could have? Violet's flashing this at me. Violet thinks it's 5. What do the rest of you think? 3? Are you doing the old 5 thing too? All right, let's talk about it. From the picture, I can see I have a root at -1. Would you agree with me? What is that thing doing at -1? It's bouncing off? That means its power, its multiplicity, is even. Now I'm doing the least possible, so the first even number would be 2. That could be a 4th, it could be a 6th, I don't know, but I want the smallest one. So that root right there, -1, happens twice. All right? I also have a root at 3. Does that one appear to have any multiplicity? Nope, zipping right through. So far, I have 3 zeros, right? But they told me in the problem that I root 3 is a root. So I have those 3, and now I have this one. But what about that one? He can't happen by himself. So as soon as they told me that, I knew I also had this one. So I know I've got a minimum of 5. Next to the 5th, minimum. Could be more than that. All right, polynomial inequalities. We're getting ready to solve some of these. Consider the function f of x above. Where is f of x equal to 0? -3, -1, and 3? Where is it bigger than 0? Oh, you guys, -3 to -1, it's bigger than 0, right? What does f of x bigger than 0 mean? Above the x-axis, that's y. Where is y bigger than 0? Above the x-axis. Or, there's another place it's positive. 3 to infinity?
Does it matter if we put like brackets or like parentheses?
It does. It has to be parentheses because of this right here. If it said or equal to, then we'd be bracketing it. Okay, which the next one does say, where is it less than or equal to 0? Less than or equal to 0 would be from -infinity to -3. And then again from -1 to 3. Is that okay? All right, let's do one little reminder. reminder box. When we write f of x, we are referring to the y value. F of x greater than 0 means the graph is above the x-axis. And f of x less than 0 means the graph is below the x-axis. Okay? Now, we just solved, basically, we solved that inequality, that last thing we just did, based on the picture. And that is a completely excellent way of doing the problem. However, in the next exercise, example 3, he wants us to do this with a sign chart. So in other words, we aren't going to use a graph. We're going to use a number line. All right? So here's our polynomial. We will have zeros at -4, -1, and 3. Does that look okay to everybody? Are you okay with my open dots at those points on my number line? Okay, so now what we're going to do is we're going to test each interval. And one way to do that, real handy, is to simply pick a number in this interval, like -5, and look at what happens to each of our factors. So if I put in -5, don't worry about the number. If I put in -5, that factor would be negative. Would you agree with me? That factor would also be negative, and that one would also be negative. So when I multiply, these are factors, they're being multiplied. When I multiplied them, I would end up with a negative result. All right, well, what happens here? Well, pick a -3 or something in here. I would have a negative, and a positive. Now when I multiply them, remember these are factors, so I'm multiplying, I get a positive result. 0 gives me a negative result. And 4 gives me a positive result. Now again, I know there are other ways to do this problem, but I'm following the directions. It says build a sign chart. That's what this is. This is a sign chart. Now, based on your sign chart, can you answer the question? Sure you can. What does this mean? Greater than 0 means positive. So where did I get positive results? Right here? And right here? So my answer will be -4 to -1, that chunk of the number line, or 3 to infinity, that chunk of the number line. Now we've talked about this before. I know the whole alternating thing, I get all that, but I'm following the directions, right? So yesterday's quiz, some of you didn't follow the directions, and remember how you have to have this, I mean, whatever your numbers are, you don't have to have the letters. That is how we do rate of change. You miss points if you didn't have that down. You gotta learn to follow the directions. If I'm an AP grader, they give me a rubric. 1 point for this, 1 point for this, 1 point for this. And everything you don't have down there is minus a point. Even if you know how to do the problem, you get the right answer. All right, so discipline. Discipline. Follow the directions. Sylvia, sit up. Are you sick? Okay. All right, try number 2 with your partner. 4, example 4. Try that with your partner.
Yeah.
No, but, oh, there's just multiple pieces. So maybe it's 3, yeah, 'cause I think the negative angle, right?
Oh.
So it's negative infinity. It just, like now, it's off, on, off. It's just like,
Oh,
it's
I'm
double.
you're right.
Negative 8. It's like he presses on.
All right, this is what I got, what do you think? Is that okay? Now, a little caution, that worked out great because these are open, or closed-in dots. What if they'd been open dots? Then I wouldn't be able to do that, would I? I would have to answer that in 2 pieces. Negative infinity to negative 2, and then negative 2 to 5. Be careful about that, right? But the way it was, I can go ahead and make it all one piece because it's all connected. Okay? Yesterday, right at the beginning or end, at the end of class, we were talking about how we can use a table of values to figure out the degree of our polynomial. We are allowed to use the differences, first differences, second differences, third differences, if what? What is the caveat there? Your inputs have to be equally spaced. So let's look, are inputs equally spaced in both charts? Yep, so start finding the differences and see if you can determine what the degree of your polynomial is. For the first one, A, did the first differences match? Nope, so it's not linear. Did the second differences match? Yep, which means it is quadratic. All right, B, did the first differences match? Nope, not linear. Second differences? Nope, not quadratic. Third differences? Yes, so that is a cubic polynomial. One more time. Don't do that unless your x's are equally spaced, okay? All right, now we're gonna talk about even and odd. I can't remember, have we done this already, even and odd functions? Definition of an even function, it has symmetry over the y-axis, and that means that whatever you plug in for x it doesn't matter whether it's positive or negative, an even function. So think about the easiest even function. Well, they give us an equation here, we'll just use it. He says this is an even function. Notice that if you plugged in a number like 1, and then you plugged in -1, wouldn't the answer be the same? That's what it means to be even. It means that when you put in a +1 and you put in a -1, you get exactly the same output. This is even. Now, odd means that you have symmetry about the origin. So notice a point on function g there, a point would be maybe, I'm going to abbreviate here a little bit, 2, -2 approximately. But you also have the point -2, +2. In other words, for an even function, for symmetry about the origin, if you change the sign on x, you will also end up changing the sign on y. Okay? That's your definition for odd. Symmetry about the origin. For even, if you change the sign on x, it doesn't change anything. For odd, if you change the sign on x, you're going to change the sign on y. Alright? So now, you get to do example 6. Are these guys even, odd, or neither? Alright, so let's do our tests. Basically, find h of -x. If it's even, what will happen? That right there. If it's odd, what will happen? The opposite of that right there. So let's put in -x. Can you tell what's going to happen? So I'm putting in -x. What's going to happen here? 2x to the 4th, yeah. What's going to happen here? Please don't cancel those negatives because that is going to cancel this one, right? So what happened? I came back with the same thing I started with. So that guy is even.
Do you want us to do it by plugging in
Yep.
x?
Yeah, that's the definition. So that's how we're going to do it. All right, how about B? Even, odd, or neither? Well, let's evaluate k of -x and see what happens. So here's k of x. Now k of -x equals -x cubed over -x minus 1. All right, let's see what happens here. What's that going to give me? -x cubed minus 3x minus 1. Now, if it's odd, I erased it. But if it's odd, this is what has to happen. When you plug in -x, you have to get the opposite of what you started with. Did I? No, that messes it up right there, doesn't it? So this one is neither. It's not even or odd. Because remember, if it's even, when I plug in my negative, I get my original problem back. That didn't happen. But I also didn't get the opposite. Now, see, these are graphs. C and D are graphs. Does that thing look like it has symmetry? C. Does it look like it has symmetry about the origin or about the line the y-axis? I'm sorry, the y-axis or the origin? Either one.
Origin.
looks like it has symmetry about the origin. So C is an example of an odd function. How about D? Does D have symmetry? Yes, but not the right symmetry. If you're gonna be even, you have to have symmetry about the y-axis, and it doesn't. Okay, good. Let's go to the back of the next page. So we're on the back of the what's up with the zeros page. All right, check your understanding, 1 through 3. Will you and your partner take a stab at it? Yeah, take a stab at it, and we're gonna talk about your answers.
Yeah, because they all add up to 6. They all have to do this here with an X because it's a 4. Yeah, so what it is actually more negative. This might be X. Oh. Why is it other
One, two, three, four, five.
Did that? Wait, I meant.
Wait.
Alright guys, how we doing? How's it look to everybody? -3, according to the picture, has an even multiplicity, so the least one would be 2. And then x equals 2. See how that thing's curving through there? So that means it's got odd multiplicity, the least one would be 3. And then 4, so I said, no to answer B, because doesn't this add up to 6? And if it's a 6-degree polynomial, then there aren't any leftovers to be anything else. Good? Okay. Then this one, I said 5. I said it had to have multiplicity 5. What do you think about that? Is that what you all said? Good? And then I wrote my equation. Oh, actually, I didn't really write an equation. Okay, I wrote my equation. I've got x minus 4 squared, x plus 2, and then x minus 3i and x plus 3i as my factors. Does that look all right to everyone? And then 3, it said find all the zeros, so obviously one of them's -6, and then I solved this and got these as the other two.
Do you have to separate them, or can you just do the plus and minus?
You can do the plus or minus. I separated them because my next task was to write them as factors, and those have to be written separately, and it's easier for me to write the factor if I have the number in front of me.
Okay, but like
It's
on
okay.
a quiz or
It's fine. If you're just listing the roots, that's fine. And so then my factors were the original x plus 6, and then x, move everything over here, so x plus 1 minus 2i, x plus 1 plus 2i. Those are called the linear factors.
For number 2, I had x minus 4 squared, x plus 2, and then I put x plus 3 squared instead of the x minus 3i, x plus 2i. Does that work?
You put what now?
X plus 3 squared?
I believe if we FOIL those, we get x squared plus 9. I'm not sure how you got x plus 3.
Okay.
Okay, and we don't want to do that because that would be a quadratic factor, and we're supposed to be using linear factors. So yeah, we don't want to combine those. These are not the same, so they won't ever be something squared. But I think we get x squared plus 9. All right, one more thing to do today, and that is the back of the next page. So the back of the Who is the Fairest of them all page. All right. Let's walk through this together. We're gonna run out of time here, so we'll go through it together. Half of the graph of an odd function is shown. Sketch the other half. right, what's your thought? What's happening to this arc right here? Where's he gonna end up if we are odd? That means we have symmetry about the origin. So won't that just end up over here like this? Now what about that guy? Well, remember what it means to be odd. It means if you change the sign on X, you also change the sign on Y. So this point right now is positive 7, negative 2. So that point would become negative 7, positive 2. Again, what does odd mean? Odd means if you change the sign on X, you also change the sign on Y. If 3, negative 18, 3, negative 18 is on the graph of an even function, what other point is guaranteed to be on the graph? Charlie?
-3, -18.
Very good. Because what does even mean, guys? Change the sign on X and nothing happens to Y. Very good. Prove your answer algebraically. Is this thing even, odd, or neither? I bet you have a gut feeling. What's your gut feeling? Do you have one? Yeah, I think it's odd. How do we prove that algebraically? Well, real easily. We're gonna put in negative x. Problem, I think. If I put in negative x, what am I gonna end up with? Negative x to the 5th minus x cubed plus 3. I don't think I'm odd. Because if I'm odd, I should come up with this, the exact opposite. And I didn't. So I'm just going to put a little notation over here, not odd. Because it's not this. I'm also going to say it's not even. Because it's not the original problem. So this one is a neither. Remember, if you're odd, you plug in negative x and get the exact opposite of what you started with. If you're even, you plug in negative x and get the same thing you started with. All right, last one, true or false? Hang with me here, true or false? Explain why it must be true. And if it's false, provide a counterexample. Okay. All even functions go through the origin. True or false? Why? Give me a counterexample. You have to give a counterexample. Is that an even function? Absolutely, but it does not go through the origin. Okay. If each term in a polynomial function has an even exponent, the function is even. True or false? I heard some trues and some falses. Why do you think it's true? Says you have to use the definition of even. So the definition of even is this. That's the definition of even. If everything has an even exponent, right? What is gonna happen? What is gonna happen when you plug in negative x's for all these? Well, they cancel out the negatives, and so you will be left with exactly what you started with. So that's a true statement. All right, next time we're gonna do some sketching with a partner, but what you're gonna do now is 1.5 homework. That'll be due on Tuesday. And then we'll kind of recap and review